IGMP snooping is the process of listening to Internet Group Management Protocol network traffic. A feature allows a network switch to listen in on the IGMP conversation between hosts and routers. By listening to these conversations, the switch maintains a map of which links need which IP multicast streams. Multicasts may be filtered from the links which do not need them and thus controls which ports receive specific multicast traffic. Purpose: a switch will, by default, flood multicast traffic to all the ports in a broadcast domain. Multicast can cause unnecessary load on host devices by requiring them to process packets they have not solicited. When purposefully exploited, this is known as one variation of a denial-of-service attack. IGMP snooping is designed to prevent hosts on a local network from receiving traffic for a multicast group they have not explicitly joined. It provides switches with a mechanism to prune multicast traffic from links that do not contain a multicast listener. IGMP snooping allows a switch to only forward multicast traffic to the links that have solicited them. Essentially, IGMP snooping is a Layer 2 optimization for the Layer 3 IGMP. IGMP snooping takes place internally on switches and is not a protocol feature. Snooping is therefore especially useful for bandwidth-intensive IP multicast applications such as IPTV. Standard status: IGMP snooping, although an important technique, overlaps two standards organizations, namely IEEE, which standardizes Ethernet switches, and IETF, which standardizes IP multicast. This means that even today there is no clear owner of this technique. This is why RFC 4541 on IGMP snooping only has the status informational despite actually being referred to in other standards works such as RFC 4903 as normative. Implementations options: proxy reporting. IGMP snooping with proxy reporting or report suppression actively filters IGMP packets in order to reduce load on the multicast router. Joins and leaves heading upstream to the router are filtered so that only the minimal quantity of information is sent. The switch is trying to ensure the router only has a single entry for the group, regardless of how many active listeners there are. If there are two active listeners in a group and the first one leaves, then the switch determines that the router does not need this information since it does not affect the status of the group from the router's point of view. However, the next time there is a routine query from the router, the switch will forward the reply from the remaining host, to prevent the router from believing there are no active listeners. It follows that in active IGMP snooping, the router will generally only know about the most recently joined member of the group. IGMP querier: in order for IGMP, and thus IGMP snooping, to function, a multicast router must exist on the network and generate IGMP queries. The tables created for snooping are associated with the querier. Without a querier, the tables are not created and snooping will not work. Furthermore, IGMP general queries must be unconditionally forwarded by all switches involved in IGMP snooping. Some IGMP snooping implementations include full querier capability. Others are able to proxy and retransmit queries from the multicast router. See also, multicast listener discovery. References